Good morning, students. Today I am going to explain about the module 3, the support reaction chapter. This chapter mainly deals with an element called as beam. A beam is an one-dimensional element. A beam is an one-dimensional element. Why it is called as a one-dimensional element? Because the length parameter is more compared to breadth and depth. So generally beam is supported at two ends. As we can see in this diagram, it is supported at two ends at A and B, and it is having a length which is more compared to the breadth and depth. So always the beam is represented in the form of a line diagram. The most important factors or most important topics we have to study in this chapter is what are the different types of supports, the first one. The second one is what are the different types of beams. Then third one, what are the different types of loads. And fourth one is what is meant by statically determinate beam and what is meant by statically indeterminate beam. So in this video, I will make only what are the different types of supports, and in the coming videos, we shall see about what are the different types of beams, loads, as well as statically determinate and indeterminate beams. So I will explain about what are the different types of supports now. The first type of support, as we can see in the video, that is simple support. A simple support where we can see at A and B the beam is supported with an simple support. The simple support is always represented with an arrow, and it produces only one reaction, the reaction at A in the vertical direction and the reaction at B in the vertical direction. That is the meaning of RAV and RBV. So totally this beam produces two reactions because simple support produces only one reaction at a particular point. So totally it is producing two reactions. The second type of support is called as a roller support. A roller support is always represented with a triangle, with a circle, or it is represented like this. Roller support always produces only one reaction again at a particular point, and it makes an angle of 90 degree to the plane of contact. It always makes an angle of 90 degree to the plane of contact. Similarly, simple support also, it always makes an angle of 90 degree to the plane of contact. Then the other orientation in which the roller support can be kept is either it can be kept in the horizontal direction or inclined direction. So roller support can be kept in the vertical direction as shown here. Either it can be kept in the horizontal direction as shown here, or it can be kept in the inclined direction. It produces only one reaction at a particular point. Then the third support is an hinged support. It produces two reactions at a particular point, RAV and RAH. So totally two reactions at a particular point. Then fixed support. The fixed support produces three reactions at a particular point, that is RAV, RAH and moment, RBV, RBH and a moment. So totally three reactions at a particular point. So totally it is producing six reactions. The total this beam is producing six reactions. So three reactions at A and three reactions at point B. Totally it is producing six reactions. Once again, I will just summarize the things what I have discussed here. Supports are very important component of this chapter. So first support is simple support. It is represented by an arrow. It produces only one reaction at a particular point. So in this diagram, simple support at A, simple support at B, totally two reactions. And roller support, it is represented like this. It also produces a single reaction at a particular point. So roller support, either it can be kept in the vertical, horizontal or inclined. It is horizontal direction, it is inclined direction, and this is a vertical direction. It can be kept in any fashion. Hinged support, it produces only two reactions at a particular point, RAV and RAH. So if I have a beam having an hinged support at both the ends, A and B, as we can see in the diagram, totally it produces, this is reaction at A in the vertical direction, reaction at A in the horizontal direction, reaction at B in the vertical direction, reaction at B in the horizontal direction. So it is having 2 plus 2, now four reactions. Totally it is having four reactions for this particular example. I'm telling for this particular example. Similarly, fixed support produces three reactions at a particular point. So, so for a beam, how many reactions are developed depends upon what are the types of support. So thank you. In the coming videos, I will explain about the next step.